Уважаемые коллеги,
Dear colleagues,
сегодня здесь, в Санкт-Петербурге, всех вас, всех участников второй международной научно-практической конференции по
we're happy to welcome
продолжающейся пандемии новой коронавирусной инфекции практическими наработками, накопленными за время борьбы с пандемией, а также дальнейшее усовершенствование подходов к профилактике, диагностике и лечению коронавируса. Наша сегодняшняя конференция, а еще раз хочу конференцию. Первую мы с вами проводили год назад в этом же зале, в прекрасном городе Санкт-Петербурге, который...
So it's the second conference here in St. Petersburg, which has created all the necessary conditions for the conference to take place last year and this year. Our conference today has brought together about 300 participants, 132 from different countries of the world who are present here personally, and many in the video conference format. We have representatives of the public authorities, of the scientific institutions, different NGOs, WHO, Eurasian Economic Commission, and CIS. Direct transmission is through the internet. The world has been fighting against the pandemic for almost 2 years, and we have extended and expanded our knowledge of the virus, and we already have some success in overcoming the COVID. Thanks to the work of the researchers, today in the world there are 28 vaccines administered, and 61 vaccine is going through the final test of final stage of clinical tests. According to WHO, at present, there are about 8 billion doses of vaccine administered. We are quite sure that these numbers are going to increase, and they will help us achieve victory over COVID-19. In spite of all the experience and knowledge, we still do not have answers to all the questions, and many challenges of the pandemic are still to be resolved. First of all, it's the evolution of coronavirus that we need to remember of. And only through joint efforts, we will be able to assess all the risks associated with the pandemic and withstand them. The conference today is unique by the number of participants and the range of topics to be discussed within the framework of the program. Now, there are leading researchers and practitioners taking part in the conference. They're all involved in the tackling of the problems of COVID-19. Representatives of Rosbudnadzor, the Ministry of Public Health of Russia, the Ministry for Defense, Russian Academy of Science, leading clinical centers, which from the very first day of the pandemic have been helping the patients, and the wide international range of specialists here and professionals. The topics we are planning to touch upon cover different fields: molecular epidemiology of the new coronavirus, the new drugs and the prospects associated with them, the clinical specifics of the course of the disease, immunology of the coronavirus, efficacy of vaccines in the context of the number of strains, and of course the concentration of experience is great, and I'm sure the conference is going to be most useful for all the specialists who are involved in combating the COVID. We are going to work for 2 days. We have 17 sections, and there is a whole range of abstracts, and we have been able to do that, and you will find there over 70 papers described there, and this is the book which we're going to present to you today, which is of practical and scientific importance for all the parties involved, for everyone who is involved in the victory over COVID. Allow me to introduce our guests of honor: the Governor of St. Petersburg, Alexander Beglov, and could we see on the screen, together with us online, is the Regional Director of the European Bureau of WHO, Dr. Hans Kluge. And I'm quite sure we will be able to see him and to listen to his contribution. I would like to welcome our partners, delegations of Armenia, Kazakhstan, Belarus, Tajikistan, Uzbekistan, Mongolia, Vietnam, and Guinea. And they are here with us both in person and online. And the political will and coordination of actions at the level of different departments is the prerequisite of victory. And of course, the government of the Russian Federation, the president, are playing key role in that particular work. And the conference is being organized with the purpose of the discussion of the new scientific data on the epidemiology, virology, immunology of the new coronavirus infection. Now, at the time of the pandemic, of course, it's very important to think about the epidemiological status. And the Russian Federation is doing a lot of work in this context. Allow me to read out the address of the head of the government of the Russian Federation, Mikhail Mishustin.
Dear participants of the conference, on behalf of the government of the Russian Federation, I'm happy to welcome you in St. Petersburg, and I wish you fruitful work. In the modern world, it is impossible to ensure social and epidemiological welfare in an isolated manner. Of course, it all depends on effectiveness of all agencies' work and coordination in a multi-level format. Definitely, coordination of all countries is needed for this. Currently, the appropriate plans are being implemented in various organizations. The World Health Organization, Shanghai Cooperation Organization, and others. Today, we're all united by our desire to prevent spreads of deadly infections. It is extremely important that this conference allows all scientists and researchers from different countries to discuss different topics, which includes influence of the virus on health of the population. We can share advancements in the sphere of treatment and prevention of the spread of the coronavirus infection. I'm sure that this conference will become another step in strengthening cooperation in fighting COVID-19 pandemic, and your advice will be needed to save lives of the people. I wish you fruitful discussions and all the best. Michael Mishustin. And of course, with great warmth, I would like to thank the governor of St. Petersburg, Alexander Beglov, because the role of this person and the role of the city administration can't be overestimated, because only during this year, the year which is ending, it has been so intense. There has been so many international, sportive, political events in St. Petersburg, and all the measures of sanitary protection have been taken, and we demonstrated that if the all organization steps are taken appropriately, then the European Cup and the International Economic Forum in St. Petersburg and other significant international events are possible. And we do need them, and there's no risk for the population. Now I would like to pass the floor to the Governor of St. Petersburg. Thank you very much, Ms. Popova, Mr. Kluger, dear friends and colleagues. Welcome to St. Petersburg. These days, it is actually 2 years since the world faced this dangerous infection of COVID-19. We have been working all together, looking for ways how to stop the spread of this disease. I would like to congratulate Ms. Popova and the Service of Protection of Rights of Consumers and Health of People for this cooperation. I would like to acknowledge Ms. Bashkirtova's and Rospotrebnadzor agency in St. Petersburg. Like Ms. Popova said, yes, all our united efforts of administrators, medical specialists, doctors, ensured that we organize various international, all Russia and regional events at the highest level. And what is most important, it is absolutely absolutely safe for our citizens and guests of our city. I would like to acknowledge the contribution of our scientists. They first in the world developed the vaccine. They identified the first steps because we didn't know what to do, but scientists were standing by our side. Then new drugs appeared, and during the first weeks of the pandemic, the PCR testing was an important goal, and only one epidemiological institute of Rospotrebnadzor could do that. And now, with the help of this agency, over 60 laboratories in Russia, in St. Petersburg, can do that. And of course, all this work cannot be underestimated. And now we have 185 centers where people can get vaccinated, and over 2,700,000 people have been vaccinated. Of course, people over 65 with various medical conditions are most susceptible to this disease. And our task is to ensure that they get the best conditions for vaccination. Dear ladies and gentlemen, dear friends, we have accumulated great experience of fighting coronavirus. Unfortunately, we are still in this pandemic, and new efforts of medical specialists and governments will be needed to fight this disease. I would like to thank you all for this cooperation. I wish you all success for the sake of health of all our people. Thank you very much, Alexander Dmitrovich. Now I would like to say a couple of welcome remarks as head of Rospotrebnadzor. And I would like to say the following. Dear colleagues, currently it is a known fact that we know that over 260 million cases of this infection have been registered, but it is not the whole picture. We see that this virus is mutating, and it was obvious during the first year of its circulation in the population, and it provides some significant mutations every 6 months. December 2020, it was announced in the United Kingdom, then April, May this year, then new Indian strain, and half a year later, now it is Omicron. All our efforts are aimed at evaluating and defining the opportunity for spreading of these mutations and how they can impact the whole epidemiological situation. The Russian Federation is doing its best taking into account this challenge. Of course, it is quite unusual. And our major task is proactive response. And this proactive response and strategy of fighting the disease that has been chosen in the country is based on the strong system of coordination between different bodies and the strong executive power and strong governance. Epidemiologists is to say that the most important thing for fighting any disease is the system of governance, and governance again. Currently, the Russian Federation is taking the 94th place among all the countries. It is in terms of the number per 100,000 people. So, and we never were higher than the 60th place, and we are in top 10 in terms of vaccination. And we see what is happening in the country very well. And this speed is gaining its momentum. And we believe that more and more tests will be taken by our population. Great attention is also given to the scientific assessment. No decisions of Rospotrebnadzor have been taken without a scientific foundation and assessment of the whole spectrum of information which is available in order to take these important decisions. And this is done by Rospotrebnadzor and also colleagues from the Ministry of Health, the Ministry of Defense, and the Russian Academy of Sciences. I would like to say that the Russian and Soviet microbiological and epidemiological schools have been among the leading ones in the world, and they were successful in fighting various diseases and small pox, for example, and we were celebrating it last year. And it all depended on the research advancements of the Russian scientists. And of course, we cannot neglect this contribution. Science has become great foundation for preventive measures, for treatment, for therapeutic measures and governance. And the pandemic has become a driver for development of various industries. And we are going to discuss it in detail today and tomorrow. The Russian Federation, in order to assess the variability of strains, we have developed special systems for assessing mutations, and also there is the Russian platform for aggregating all information on virus strains sequencing. The results that are obtained in Rospotrebnadzor institutions and all organizations that are involved in sequencing this new virus are accumulated on that platform. Now, in Russia, Delta is most prevalent, and we will continue this monitoring. I would like to say that with support of the government of the Russian Federation, the scientific institutions have been supporting viral monitoring of partner states, and we work together with Kyrgyzia, Armenia, Belarus, and we are expanding this cooperation. This enables us to see the variability of the virus in a bigger region of the Commonwealth of Independent States and the Eurasian Economic Union. The scientific institutions developed criteria for various restrictive measures and lifting depending on the situation and on the basis of immunology studies. Various institutions of Rospotrebnadzor, including the Pasteur Institute, which is situated in St. Petersburg, have been implementing the program of studying the population immunity in Russia, in member states, in Eurasian region, and this is a unique program in terms of the coverage and the period of studies. And now we study not only post-infection but post-vaccination immunity. And we study both on the basis of one person. This methodology has been developed by the Pasteur Institute, and this work is done in 26 regions of the Russian Federation, and similar cohorts of volunteers is 74,000 people, and this is a lot for this study. And now 5 stages have been finished so far. The population immunity study, this work is organized not only in Russia, but it is done in Belarus, Kazakhstan, and they are preparing it in Armenia and Serbia as well. To date, we have a study on evaluation the population immunity among children. And in December this year, we are studying the volunteers cohort of the age of from 1 to 17. It is important to develop diagnostics measures and instruments. And the test system that is developed by the Vector Institute, it was last year. It took them 7 days to develop it. So it is functioning, and it is as effective as it was last year. We would like to say that development of technology and development of new test systems, including LAMP and isothermic reaction technology and IHA method, all these have been developed by Russian scientists, and all this is used in Russia. An important area is digital measures. Upon the order of Russian government, there's a mechanism of transferring all results of PCR tests and antibody tests. And all the labs of the Russian Federation where these tests are taken, they are connected to this digital system. So it is both virus testing and antibody testing. And not later than 60 minutes later, after the result is received, this information appears on the personal page of people who took this test. And all these results are very fast and high quality, and over 7 million, information on about 7 million tests have been transferred already. If we speak about cross-border traveling, so there is a mobile app. It is called Traveling Without COVID. And this is a modern solution that ensures a transparent crossing of the borders. And this app provides high quality of results of COVID-19 testing. And now almost 1,300,000 people have been using this app, and over 3 million tests have been included. Another important contribution is what we do for international cooperation. As we heard from Mr. Beglov, it is impossible to fight this disease at the level of one country or the region. That is why our institutions are involved in international work. About 30 missions have been done for partner countries in the sphere of fighting COVID-19. 31 mobile apps were supplied to 10 countries and lots of test systems. So this has been done during these 2 years. With support of the government of the Russian Federation, only Rospotrebnadzor is implementing 10 projects with 16 countries, 6 projects with CIS countries. It is supporting their material and scientific base.
This year is quite a special year for us because 2 of our scientific centers have acquired the status of the cooperating centers of our WHO Vector Center, which carries out the monitoring of the virus, of the flu viruses, which could lead to a new pandemic this year, together with the Russian system of surveillance. And at the early stage, we revealed the dissemination of the strain of the bird flu, and so we also revealed the infection of a human being with H5N1. So Vector is the cooperating center of WHO. It's number 7 in the world, and the second center in the world, which is going to study the highly pathogenic flu viruses, along with one of the centers from the United States. And the Microbe Center is one of the most important from the point of view of rapid reaction. And on the 12th of November this year, Russian anti-plague Anti-Plague Institute of Rospotrebnadzor has also acquired the status of the cooperating center of WHO, following its reaction to infectious diseases. Among the authorities of that particular institute is the support with the assistance of different mobile units, the strengthening of the human resource potential, and the technical and material support of the sub-regional networks of the respective countries, following the regulations in the context of sanitary epidemiological rules of the world. Now, in Kazan this year, together with WHO, we were able to demonstrate our skills, and we organized the rapid reaction laboratories exercise, so to speak, and the CIS countries were involved in it: Belgium, Germany, and France. During that particular exercise, the standards were tested for the laboratories. They will be in the basis of the standards prepared by the WHO. The experience of the pandemic emphasized another very important topic, namely the importance of science and scientific research, not only in the epidemiological work, but also in case of the pandemic, because there is a negative attitude to the anti-epidemic measures taken by the governments, and this attitude is expressed by the population. Now, the experience of the applied work in the field of biotechnologies, microbiology, we can see that it's necessary to build a proactive system of combating the future potential pandemics. And in Russia, this work is being done. The president of the Russian Federation, Putin, in his address to the Federal Assembly said, "We need to have a reliable shield protecting us against epidemiological threats." And he spoke in the same context about the innovation-based programs, which might be able to get the status of the projects important for the interests of the state. All this work, of course, is very important for the strengthening of the whole system of epidemiological surveillance, including the laboratory that need to be created and that need to be consolidated and made stronger at the whole area of CIS. Now, artificial intelligence, different digital methods and technologies are being introduced into this work, which will make it possible to control the system and to carry out the forecasting. Modernization of laboratories is very important. And of course, the anti-plague institutions should be taken special care of with the updating of them in order to leave a positive level of epidemiological safety. The new platforms will be created, which will enable us to work on the new drugs in case the new dangerous infections appear. The Eurasian Shield is possible if we carry out joint monitoring work through the creation of a single epidemiological environment on the basis of the data exchange with the help of the different approaches, but well coordinated. And of course, this sanitary epidemiological control should be strengthened at the borders of the states. We have already signed the respective agreements between the CIS countries. We have the organization established already, the work of which is focused on the prevention of the epidemics. And also the purpose is to examine the focal points of potential spread of different infectious diseases in different countries. Once again, I need to go back to a very important publication, which is right here in front of me, and I'm quite sure you have it. It's the book, COVID-19, Scientific and Practical Aspects of Fighting COVID-19 in Russia. The results of this research work is focused on the examination of the specific molecular characteristics, development of preventive measures, and the experience of the implementation of everything that has been achieved into the practical work. And COVID-19, the practical aspects of work with the pandemic in the Russian Federation. That is the title of the book and the chapter, the specific chapter dedicated to this particular issue. So A lot of attention in this book is paid to the organization of anti-epidemic work, sanitary work, mass testing, and interdepartmental coordination, safety and security measures when organizing medical assistance and laboratory work, which is very important. Alexander Dmitrievich mentioned that, and at the beginning of the pandemic, we had just dozens, maybe just 100 laboratories that could work with the pathogens of this type. Very quickly, we taught practically all the laboratories to work with the pathogens of the third and fourth group. All this knowledge, all that experience and competences presented in the book. We tried not to lose any of the knowledge acquired, because this is new knowledge, and we had to change a lot very quickly, much faster than at any other period of time. We had to find new solutions. Some were effective, others were not that effective. But all the experience is there in the book, and I would like to thank the authors. The authors are practitioners and researchers from Rospotrebnadzor, from the centers of epidemiological centers, and I would like to thank everyone for their work and for the participation in the compilation of the monography of the book. Speaking about the population, I would like to mention here the coordinating role of WHO in the implementation and carrying out of different international efforts focused on the protection of the population against infectious diseases, particularly if the situations are emergency situations and in the field of sanitation and epidemiology. I would like to thank particularly the European Bureau of the WHO for their special attention to our countries. Allow me to give the floor to the director of the European Bureau of WHO, Dr. Kluge. Dr. Kluge, we would like to hear a few words from you. Esteemed Professor Popova, the Governor of St. Petersburg, delegations and colleagues. The pandemic, COVID-19, has been able to, through innovations, to save many lives through our work. At the same time, the pandemic strengthened and deepened the inequality in the context of the exchange of technologies and instruments. Today, we can divide the pandemic into 4 stages. The first 6 months in 2020, we could call them the time of uncertainty. At that period of time, we worked on the sequence of the virus genome, and we wanted at that period of time to find the protective measures. Exchange of information was very important, and there were bans on exports at that time. The global supply chains were damaged as a result. In the second half of the previous year, there appeared the first results of the international cooperation, and the results of following recommendations. There was also the information exchange on the strains of virus. At the beginning of 2021, there appeared vaccines. We can radically change the situation with the promise to provide just approach, and there was an unprecedented campaign on vaccination. Some countries began to share vaccines with them, while other countries were just accumulating doses of vaccines. Now, at the end of 2021, the states of WHO have taken a historic decision on the increase of the international cooperation within the framework of the global agreement on the readiness to the pandemics. At the market, there are emerging new drugs new ways of treatment, and our region is a center of the accumulation of knowledge on COVID-19. Our success in combating COVID-19 and threats for health is based on two pillars: science and solidarity. Science explains how the virus develops, what strains of virus emerge, and what particular ones are avoiding immunity, which drugs are capable to fight the virus, and in the end, what the end of the pandemic is going to be like. Solidarity helps to achieve the serious success within the countries and at the international level. And facing this global threat, science and solidarity, realizing how important scientific institutions are. This year, the research centers working in the field of virology were able to get the status of the cooperating center of WHO. I'm talking about the Vector Center, because they're talking there in their work about the ecosystems of people and animals crossing. And that is the Saratov Center that is doing this work. And they also are allocated a special status for the use of the mobile laboratories in this particular context. And I congratulate you with that. Now, the status was accorded to two Russian institutions, and this emphasizes that altogether we are focused on cooperation in face of the global threats. And, of course, this will definitely help us improve our potential and will help us carry out the proper assessment of the actions in emergency situations on the basis of knowledge and practical experience. The pandemic is far from being over. And with all of that, we can see a number of other threats to health. And for that reason, I do hope sincerely that the countries of Europe and Central Asia will not lose their belief in science, and that partnership between the Russian Federation and WHO will continue its development. And we will together do everything possible to improve the health of our people. Dear friends, I wish you fruitful conference. Thank you. Thank you very much. Thank you, Dr. Kluge. Thank you. Dear colleagues, now, the official opening of the conference is over with that. And allow me to announce the launching of the first plenary session, COVID-19, Epidemiology, Virology, and Immunology. And allow me to give the floor to the director of the Russian Microbe Institute, Anti-Plague Institute from Saratov, Vladimir Koterev. Thank you. Esteemed Anna Yurievna, Alexander Dmitrievich, and colleagues and counterparts, allow me to present my presentation to you. It will be dedicated to the epidemiological aspects of the pandemic.
And I would like to say straight away, and this is what Anna Yurievna has mentioned already, the pandemic is associated by infodemia. And of course, this has a great impact on the overall situation. We can say that WHO defines infodemic as a great mass of information which influences the information flows. And here in this slide, you can see the speed of spreading information, and it is happening online, of course. And all this creates a certain environment for the overall situation. And there's a Dunning-Kruger effect takes place when metacognitive information leads to distortion of the reality. On the agenda, we have a report which is devoted to this topic specifically, so now I'm not going to speak about it. So here you can see some terms and definitions. Okay, so what is COVID-19? It is an infectious disease. And all these definitions and terms, they have had a certain evolution of development and potential acute respiratory infection, SARS-CoV-19. So it is still relevant. As for the epidemiological situation, Ms. Popova touched upon it, and it is quite well known. But as for the measures for fighting the pandemic, these are classical measures that were developed by many generations of our predecessors, beginning with the Soviet times and nowadays. And next year, we are going to celebrate 100th anniversary of the sanitary service. So this is a whole range of various sanitary norms. And usually all the boundaries are identified. Of course, there's a laboratories provision and various non-specific measures. And one of the main instruments in the hands of epidemiologists, it is vaccination. And we are speaking about proactive measures from the very beginning of monitoring. And it began in Russia in December of 2019. And the dynamic development of the situation enabled us to include the proactive model of extraordinary situations response. So we have lots of norms and regulatory documents that included the experience of all previous generations. And this enabled us to prevent bringing of this virus from China, where this outbreak was registered. And we had some time to prepare the whole healthcare system and the country for the encounter with this deadly infection. The high levels and mortality related to this, okay, this demonstrates the nature of this virus. And we introduced the system of various medical, biological, technical measures in order to protect the environment and personnel from this infection. Of course, at first, there were a lot of cases among medical specialists, and it was obvious in many countries, Italy, for example, and laboratory workers, they got infected. And that was one of the major characteristics of the epidemiological process during the first stages of this pandemic. And in Russia, we took unprecedented measures in order to prepare laboratories, clinics, medical institutions, and to ensure all conditions for people working there. And it was all aiming at epidemiological safety ensuring. And all this work was most effective and efficient. I would like to speak about that the human population is heterogeneous in nature, and the infection itself also has this characteristic. And if previously we were looking at the interaction of different viruses and infective agents, okay, we were looking at through the magnifying glass at them, and after analysis of interaction of the virus and the population it interacts with, and here we're speaking about people, we are looking using a nuclear microscope, very powerful microscope. Speaking about clinical specificity of this disease, they have been studied quite well. But in terms of epidemiology, we know that some people do not demonstrate any symptoms, and actually they still can pass on the disease within 1 or 2 days. And this plays a very important role in the COVID-19 epidemiology. So this symptomless transition, and it takes about 20% of all the cases. This influences the reliability of temperature measuring, and of course it makes it more difficult to identify the source of infection. So the unique, specific feature, it is symptomless cases. It is impossible to investigate, to identify sources, and it is impossible to identify them using temperature measuring. So this influences a lot the whole epidemiological process. I would like to stress that the classical epidemiology teaches us to organize various targeted measures, quarantine, for example, or isolating the zones of outbreaks. This is regulated by federal law. This prevents infection from spreading, and it is a targeted system. What new things we have added? Lockdown. This is the regime when people are limited in terms of their mobility, and also during various emergency situations and public unrest, certain measures are introduced, and these measures are introduced for the whole population. So this is done in order to reduce the mechanisms of spreading the disease. The lockdown mechanism, this is something that we had to impose, and of course it has lots of economic and psychological negative aspects. So this is an extreme measures, and its effectiveness is not always very high. In this slide, you can see that there are restrictive measures, and this RTR factor, okay, how do they influence, for example, remote work, closing stores, banning various mass events. All this has a great impact, and this RT rate is quite high. But when these restrictions are lifted, we don't see that the curve of all the cases is going up. So Australia has introduced, if I'm not mistaken, this lockdown for the 6th time. And this rate shows that in 2 weeks, okay, the reduction is 0.61. But when these restrictions are lifted, then the growth is 0.21. As for the economic damage, Of course, it influences the intensity of the epidemiological process, but we limit this not only in terms of the regions, but the timing as well. So we had quite great successful programs in different regions. For example, when a week of holidays is announced all over the country, and this prevented introduction of lockdown in a number of regions. Then big cities as drivers of epidemiological process. There's a comparison of Moscow region, and St. Petersburg. And the major conclusion that we can take it is that first, there is a sharp rise of the number of infected people in big cities in comparison with other towns of the region. Another important aspect it is that during these 2 years of COVID-19 development, we can observe seasonality. And here, on the basis of metadata, this is an analysis of world population. And we see that these peaks, these spikes, so they are registered approximately every 120 days. And from 2020, we see that these 17-week cycles, they are repeated. And first, it was observed at the beginning of 2020 because the infection was spreading globally. Then new instruments. Okay, COVID-19 led to introduction and a usage of new instruments. First of all, it is mass testing. I'm not going to give you any examples, but we see that great dynamics is observed. The first test system appeared in January of 2020, and only several state centers, just Vector Center and 15 laboratories were doing that. And now it is a mass process, and diagnostics is done in over 1,200 laboratories. And also there's a lot of work related to development of these systems, improving their quality and ensuring biological safety. Another instrument, and there will be a separate section devoted to it, it is mass testing, PCR, laboratory diagnostics. So this is molecular genetic monitoring instrument. And for the first time, the situation with COVID-19 enabled us to introduce the molecular genetic monitoring methods into our practice. And we heard already about the national platform, and there's a number of other platforms. And in my opinion, we have here a very important goal to combine all of them.
Because this tracing of the changeability of the pathogen is most important. Moreover, the molecular and genetic monitoring is an instrument in the hands of epidemiologists, and in the near future, it's going to turn into a routine and will help us to decipher the outbreaks. And as for the evolution of SARS-CoV-2, we can see that the situation makes it possible to select the most virulent variants. Chronic infections create conditions for the manifestation of the new pathogens, and therapeutic treatment also has its impact. The immune response, insufficient immune response, also creates a selective selection of the activators. And this makes it possible for us to build a trend which indicates that, first of all, the efficacy change of the reproductive indicator as compared to the original option. And here the slide demonstrates it. We can see the initial Wuhan option and strain, and you can see that it changes towards Delta and Omicron. Not everything is clear here, of course, but we can see that the main evolutions, the main elements of evolution are associated with the quick transmission from person to person, which theoretically should also be associated with the lower virulent ability. And as for the gen variants, alpha was dominated, then delta dominates at present, and this has been proven. As for the pneumonias that we can observe today, this also indicates that. And the secondary focuses, that's also very important, as well as RO, which indicates a high level of virulence. And this all indicates that actually it's much easier for these strains to get disseminated. And in November 2021, almost 80% of all the circulating viruses are associated with Delta. And molecular diagnostics has been introduced. The PCR are there, and different types of diagnostics are there, of course, and sequencing, of course, as well. And finally, I would also like to say a few words about the effects of vaccination. Vaccine for COVID-19 applied today reduces the risk of severe and disease and terminal outcomes. And this is typical of the vaccines in general. But it does not defend absolutely from the transmission of since the we can see that there are 42,000 observations associated with Pfizer and AstraZeneca, and then they indicate that the strains explain the efficacy of the vaccines and the family focal points with COVID-19. So as for the as you can see for Britain, the contacts are clearly indicated. So the vaccinated 25%, non-vaccinated 38%. That means that the sources can be vaccinated people as well. Now, in this context, of course, there is a need to create the vaccines of the new generation, and we will have a whole session dedicated to the new vaccines. But the demand for the new generation of vaccines that can be included into the national calendar of preventive vaccination indicates that the sustainable immunity that provides good protection against infection as such is a super task which we are facing when the new generation vaccines are being created. The long-term immunity is very important for at least 1 or 2 years, and of course efficacy and safety for different age groups, considering the heterogeneity of the population. And as COVID-19 acquires the characteristics of the seasonal flu, well, of course, that means from immunization we need to move to the planned campaigns in order to prevent the uprise of the number of the infected patients. And finally, I would like to mention something that has already been mentioned. And now the scientific progress is well represented here, of course. In January 2020, we knew very little about the pathogen, about the clinical aspects, and about the treatment. And that is why This infection was considered to be very dangerous, and it was associated with a second group of pathogenicity. Today, we can see that there is a lot of data, and at the conference we're going to present the data. Anyway, this data indicates that we know quite a lot, we can see a lot, we understand a lot, and we hope very much that the trend for seasonality and the transfer to the third group of pathogenicity is not that far away from us. And the Sanitary and Epidemiological Service of the Russian Federation has a lot of experience, and that experience over these 2 years of the pandemic has been expanded, and the president of the Russian Federation mentioned that, because we are creating a very reliable shield in the sphere of sanitation and epidemiology. And the main purpose of this shield is epidemiological shocks without lockdowns. Allow me to thank my co-authors from Microbe Institute Safronova, Krasnova, Chernouhov, Ivanova, who contributed into the preparation of the presentation. Thank you. Thank you for your attention. Thank you, Vladimir Viktorovich. Now, our next speaker is Oleg Tatalan, director of the St. Petersburg Institute of Immunology and Epidemiology, named after Pasteur, Immunology of COVID-19. Dear colleagues, my presentation will be uploaded, and I will start. Now, as for the immunological studies carried out by our institute, yes, no, we need the presentation. I can just say that addressing the organizers, we need the presentation either now or we need to know when. Right. Okay. Right. Done. So our institute examines the immunology of COVID-19. And practically, these are all the major aspects associated with the studies of the immunopathogenicity and the contribution of this knowledge into the diagnostics, into prevention, and into treatment. And we all know about the role of studies in the immunogenicity of this infection. And in our studies, where we assessed 48 different moleculars, in the acute phase, 18 moleculars were demonstrating a high level, which is not surprising at all, which is within the concept of the cytokine storm. But as for this phase of reconvalescence, 8 moleculars of cytokine. And this phase occurs after 1.52 months. And this clearly demonstrates that there is a developing immunodeficit status, which can be in the basis of the post-COVID syndrome. And let's look at what those 8 cytokines. These are mostly moleculars that regulate the maturation of lymphocytes and their proliferation. If we go to the acute phase, then when we investigate And when we find this cytokines with the severely suffering patients before the infusion therapy and hormonal and anti-cytokine therapy. 8 of the listed here are interleukin 8, 6, 15, 18, and they have a sufficiently good informative characteristic for the forecasting of the outcome, whether it is going to be lethal or it's going to be benevolent. And these information characteristics is never higher than 85%, but the combination of interleukin 18 and 6, these cytokines provides us with the quality improvement and 97% level of information and possibility to forecast, which is very positive. Another aspect is the search for the biomarkers for the sensitivity and resilience to the infection. And here the analysis of the system provides us with a very good result. And 002 and so with a cohort of 128 patients and 29 at the same time are representing immunogenetic factor. We're actually approaching 500 in the cohort. The preliminary results have already been published, but the data I am demonstrating, that is preliminary data, and the significance, the protective importance of allele 02 has been sustained with the new sampling. But if we, only in case of the classical strain, but with the Delta strain, that's a different strain, so this marker doesn't work for it. And there are 2 other candidates, 2 other markers which are listed here. Of importance here is the role of the immunity and B cells, first of all. And we can see here that here a significant role is played by the cosmoplasm at the periphery, both at the acute phase and the phase of reconvalescence. And the reverse situation is also seen here for the memory cells. And different subpopulations of these cells, of the memory cells, reacting differently. And this is something to be examined at the next stage. Another stage of humoral immunity, that is antibodies. Antibodies, the quantitative approach to an protein that demonstrates that this analysis provides us with much more information. Here you can see the dynamics and the decrease of the number of the antibodies within 6 to 7 months. And the further variations are mostly associated with the fact that the person regularly encounters the virus, and the immune system reacts in a proper way. A different dynamics is for the for the post-disease immunity. These antibodies function at a longer period of time, and their level depends on the severity of the disease, and with acute and severe forms reach the highest possible levels. Now, there is new data obtained for the analysis of the antibodies in the context of different subclasses of IgG, and the analysis of all the subclasses demonstrates the role of the antibodies that belong to G3. And this is of importance, as you can see. It's of importance with different variations of the disease depending on the severity. Why G3 is so important for us, and why does G3 work like that with that infection? G3 differs from all the other subclasses considerably because it is more active. it is more actively involved in the realization of the effect. The functions here listed in the upper part of the slide, and the four characteristics represented down below show that it is weaker than the other subclasses. There's a norm of correlation here to the right. G1 dominates, and on the left there is a situation that we can see with COVID, when 80% are the G3 antibodies.
Another quite big work that we are considering humoral immunity here, and these are markers that are being evaluated. This is a population study. And I would like to quote Joffe, academician Joffe, Studies and Research, who is not only one of the pioneers of epidemiological immunity in Russia, but he also formulated the major areas of evaluating the collective immunity. During the Soviet times, there was a project which is called Immunological Map of the Soviet Union, and that project that was launched by Rospotrebnadzor in the middle of last year. This is a logical continuation of our predecessors' work. And here we are absolutely sure that COVID-19 epidemic became a litmus indicator for epidemiological area development in Russia. Speaking about the population immunity, what is important, not only the percentage share is important, and now we speak about 90 or even 95%, but also the even spread of this. And this even, this is a key word. And this is what we were taking into account when the algorithm was developed. And it is the technology of implementing this population study, because 26 regions all over the country are taking part in it, and 8 research institutions of Rospotrebnadzor and 20 territorial branches. They took part in it, and of course without clearly defined technology it wouldn't be possible. Right now 5 phases have been finished already, and we see there's dynamics, and approximately there are 2 subgroups. The first one, thank God, it is the biggest one, 21 regions, where we see there's a growth of the seroprevalence, and 5 regions where this seroprevalence is not observed. At the beginning of this epidemic, we were observing a direct dependence of the higher morbidity, the higher serum prevalence. At the same time, at the point where we are now, these data, which have been obtained from our Belarus colleagues, it is the other way around. The higher prevalence, the lower the morbidity level. And the collective immunity among children is a separate topic. Initially, we saw that the maximum level of seroprevalence was typical not only for children, but for children up to the age of 6, 7, or maybe 10. With development of the epidemic, you see the situation was changing, and in different regions, this group of children and serum prevalence has been increasing. And during the 5th phase, we observed that this circle is shrinking. Definitely, there's a certain contribution of vaccination that is being rolled out among adult population. And we need to focus not only this serum prevalence, not only the share of the people who are serum positive, but also we need to consider the number of people with very high count of antibodies and very low count of antibodies, we see that there's significant dynamics, and we see that children's group is markedly different. And it is a logical continuation of this population study. We are going to focus on kids because especially during the 5th phase, when on the 4th one there's this cross changes that took place, and we see a totally different process of humoral immunity formation among children. So this technology of studying has been introduced in many countries, and they successfully use it. And also there's several countries that are preparing for it. Some major results, not all of them, but major results, specifically about the Russian study, they have been published not only in the national but international publications. And the last point I would like to underline, it is how vaccination is affecting it. This might be used for assessing the effectiveness of vaccination. These are the results of research that was carried out in Belarus, where we saw for the first time that it is possible to assess post-vaccination immunity. And in terms of vaccination, if we have people who had this infection but didn't show any symptoms, so we, in this case with vaccination, we have a higher immunity because this body met this infection several times already in natural and artificial conditions. If we speak about vaccination, people who didn't have any symptoms, so seronegative share is less than 1. And among other groups, it is over 3%. So this is about 9 times higher. Our institute is involved in EpiVac Corona vaccination development since April. And we study this, and we see that after the whole cycle of vaccination, you see all the levels of the immunity level. And this graph demonstrates a difference of dynamics of humoral immunity. So at the bottom, you see those who did come across this infection in the past, and on top, these are serum-negative patients. Right, and now in conclusion, I would like to thank all the people and institutions we've been working together and whose work contributed to this presentation. Thank you very much. Thank you, Oleg Artyomovich. Thank you for this most interesting presentation. Now I would like to ask Vitaly Zverev from the Research Institute of Vaccines, named after Mechnikov. And he is going to speak about vaccines against COVID-19, advantages, disadvantages, future development. Esteemed Ms. Popova, esteemed colleagues. Again, there's some technical difficulty. Okay, everybody knows these numbers, so I'm not going to quote all this. Yeah, the epidemic of COVID-19 is still going on. And as soon as we realized that this virus is very serious, and we were facing very difficult times with this infection. And of course, all the people who are involved in fighting infectious diseases, we all realize that without a vaccine, it is impossible to fight this disease. At least the experience of humanity demonstrates that you can fight the infection if you have a reliable vaccine. Okay, so, and here I'm going to present some data, what we have reached and achieved with these vaccines. We have heard already about this new virus and how it interacts with the immune system. So I'm not going to speak about the same topic because when I was preparing, I was planning to show it in order to explain how and what works or doesn't work. This slide shows how important it is to start not only humoral immunity, so not only antibodies should be developed, but also cell memory should be activated. So what should be activated for this vaccine to be functional? Okay, because when the first vaccines appeared, what happens? So there's some cellular response they launch or activate. And of course, after vaccination, we always understand that this should be both humoral and cellular response, and this will determine how long this vaccine will be efficient, how long this immune response will be provided for. And of course, those markers that are needed for this effective response can be provided only if, and here in this slide, all this information is shown, what immune response should provide, what its action should be like. So this antigen-presenting cells, this should be activated, and all these T lymphocytes and all these memory lymphocytes, and so on and so forth. So, and of course, this should ensure their presence in the lymphoid tissue. And we were working with live vaccines, vaccine against the natural pox, smallpox, and poliomyelitis, because it ensures a lifelong immunity. Just a second. So we need to understand that effectiveness of immune response is determined by the nature of the antigen, and then age of the person, and lots of other factors that are important for making this vaccine effective, especially if we are going to use it for a mass population. I apologize for mentioning all these pretty obvious things, but it is important for everyone to understand what is our aim, what we have already, and where we should be. Also, should be taken into account. I know that some immunologists are saying that there's no congenital immunity, or whatever term we might use, but whatever is related to cellular.
All the vaccines, and this is a known fact, they all evoke immunity following different mechanisms. The live vaccines and these are vector vaccines as well, which are based on the live virus, and the DNA vaccines, which follow the same principles. And so these activate the congenital cellular response, and they're much more effective than other vaccines. The protein vaccines have a different mode of action. Here in the table, I represent the difference in the context of the immunity caused by the inactivated and live vaccines. Have a look. Now, first of all, they're different by the antigen and target, and they by the antigen presenting cells, and by the first and the second class of compatibility. Specific cytokines are very different, the dominant immunoglobulins. And so when we create a new vaccine, we definitely, first of all, should think of the nature of this vaccine and then activate the respective mechanisms. And so when COVID-19 appeared, then everyone immediately began to look for the antigen determinants, which we need to be oriented in order to evoke the effective immune response. But, with SARS, it worked. And so in the end, it became possible to localize all the areas which we can be oriented at administering vaccine and evoking the immunity. You can see the epitopes of SARS-CoV-2 N and S proteins. And I really would like to mention that practically all the vaccines are orientated at the surface protein, S protein. And as it was shown earlier, obviously, this internal protein and its impact is extremely important for the inner immunity. Here you can see the epitopes that we have discovered in the coronavirus proteins. There are so many of them here. Some of them are easily recognizable for the compatibility with one complex and the second complex. And so we really should understand what particular pathway we select from the very beginning. Here you can see the present-day platforms on which the vaccines are based. DNA, subunit, vector, live, and so on. The first vector vaccines appeared, and that was Sputnik V, developed in our country on the basis of 2 adenoviruses. Then the second was the platform on the basis of pathogens, live, semi-killed, and attenuated. We have 4 vaccines on the basis of those. And then the subunit and peptide vaccines, recombinant vaccines, which have a very different principle of action, Epivac Corona. And one is an improved Epivac Corona, technologically improved. And then 2 American vaccines, DNA vaccines, which also contain the S protein. And unfortunately, now I looked at different papers, and I can tell you right away that today I'm not going to discuss the work of Epivac Corona and Epivac because the trials have not been finished yet. The authors should be the first to speak about the advantages and the benefits of their vaccines. I don't like when our colleagues from different other institutes begin to talk about some vaccines not working or properly working. This is improper. This is incorrect, and we should wait for the end of the trial, because not that many people have been vaccinated with those. And this has been demonstrated today, how we understand all this. And these vaccines do work, and they make their contribution into the pandemic combating. But they're all oriented at S protein, and for some reason on the domain and the receptor, so the receptor tying the domains, of course, the binding the domains. So well, the virus changes, and it changes the domain, first of all. And that's for sure. And the efficacy of the vaccine with the change of the structure will definitely change. And it does happen, indeed. Here you can see the registered vaccines and the safety and the efficacy of the vaccines. That's what the authors present. Well, it might be so, but I'm worried about the following. WHO quite recently published this table with the number of adverse events and even mortalities, which required and the severe cases. Yes, we can see that over 50 years of the application of vaccine against paratitis, there were just about 70 cases with adverse events. Measles, about 2,000. Now, prior to that, anti-flu vaccines, 240,000 within 50 years. And as for coronavirus vaccines, already 2,250,000 registered deaths, and that's a lot. Well, ours are not there. So, but we should understand how severe that is. And the situation is not that easy and simple, indeed. So this is what the authors demonstrate. They demonstrate the reduction. If we take the American vaccines, particularly Moderna and Pfizer, that's the reduction by 30 to 40% once the Delta strain came. So they lost their efficacy, and nobody knows how they're going to work against the new strain, which has just emerged. So vaccination. How does it impact the epidemic, the pandemic? Here is the data we can show. The dynamics of the number of incidents has been increasing along with vaccination. Now, I might assume why this is happening. Because the dynamics of mortality here is also similar to the other dynamics, that was lethality. Now, recently we discovered an interesting phenomenon in several countries where there was no COVID to begin with, but then it appeared. The red, that is the incidence and mortality, and the incidence began to grow after the mass vaccination. But they mostly vaccinated there with Chinese and American vaccines, and mostly Pfizer and some others. And the same, the same happens to mortality in Mongolia, for example, these four countries. Singapore, there's a similar story. Cambodia, and then the final two slides for the Seychelles, where previously there was nothing at all, but they started vaccination, and maybe that is the imported problem. But it's obvious now that the vaccinated people, unfortunately, do not, well, they are still transporting the virus, but as they are vaccinated, they believe that they can behave in a very different way as compared to the non-vaccinated. So they do not follow the elementary sanitary norms that are recommended, the social distancing, the mask wearing. Maybe that occurs because of that. We don't know. Maybe we have not reached the highest point of the vaccine efficacy, but they do not work to 97, 99, or even 96% effect. That's our data from the same article. Now, there was a serious question. Of course, in America, they started the third circle of revaccination. And now they're talking that they should revaccinate people after 4 months. But the vaccines that we're discussing today, they're probably stimulating exclusively the appearance of the antibodies. They affect the humoral immunity, but not the memory. So the antibodies get exhausted. For some people, within 6 months, for others 2 months, and some do not get them at all. And when there are practically no antibodies, since there are no memory, no cell memory formed, the person is prone to infection again. But, well, of course, all the manufacturers of vaccines insist on revaccination once in 6 months. But we should understand that the vector vaccines, when we bring them into the body, we first of all vaccinate against vector. And vector, that's a full-fledged immunity, first class, which is very reliable immunity. And the cell immunity is part of that. But to the carrier, to the virus that we have placed into this or that gene. But here are 2 new vaccines that are being tested in Russia. One is almost ready. The other one is being tested. It's on trial. So here is what I would like to say finally. First of all, should the new vaccines be made? Yes, definitely so, because we need vaccines that will cause full-fledged both humoral and cell immunity. Should we consider the fact that the virus changes its structure? Yes, of course, yes, sure. But with all of that, at least now, according to the data we have concerning the reconvalescent, no one says that a person who has suffered from the Chinese or Brazilian option suffer from Delta strain as well. All those who were infected initially have been able to get infected very rarely, and this very often depends on the immune system of a particular individual. Anyway, a person who has gone through the disease, then, of course, the immunity might exist for a longer period of time. If we take SARS, then the immunity with some works for 15 to 17 years. So, first of all, we should work with the part of the population who are not vaccinated. People who are reconvalescent, they are the gold stock of ours, and there is not a single paper yet that says that a person after the disease can be a carrier of the virus. The immune system destroys the virus as soon as the virus appears, and the share of the dose of the virus that might exist in the throat or the nose of that person is non-infectious, is too low. But if we take the new vaccines, there are synthetic vaccines appearing. They're bringing together different epitopes. I think this is a very promising pathway. At the Institute, we were able to get the attenuated strain of coronavirus which grows at lower temperatures. We examined it, and we were able to show that there are 17 mutations. 17 of them are meaningful. And you can see that they're not only in the protein, they're also in the N protein and some regulatory proteins. So the main goal at present is to examine fully the pathogenicity, changeability, monitor the level of the population immunity, and to create the specific antivirus drugs, because the mortality is in our country is higher than average global. Create new drugs and new vaccines. And here or elsewhere, we should discuss the vaccination of children. I don't think that we're ready to vaccinate children yet. Well, of course, it's up to those who are working on the Sputnik vaccine. But on the one hand, they say we need to modify this vaccine for the new strain. And we'll start immunizing children with using the new option. No, that's a problem.
Vitaly Vasilovich, hello. Sorry, I would like to remind you about the time frame. Sorry, please, it's not the time for the discussion. Yeah, because, yeah, definitely there are lots of questions in the audience. So there will be a time specially allocated for discussions. Right, because, so let's do not get into discussion. This is a very important topic, and such discussions should be organized. And in conclusion, I would like to quote Ilya Mechnikov, who was absolutely right when he said this. You can see it on the screen. Thank you very much for this most interesting report. Yeah, and you identified a number of discussable topics, and I'm absolutely sure that during sections devoted to different topics, we are going to continue developing all these aspects. Yeah, it is extremely important to study the dynamics of mobility and incidence in terms of various clinical forms as well. Because last autumn and this autumn, they are different in terms of the severity. Because if last year primary pneumonia was observed in every 9th patient, but this year it was every 5th or 6th patient. And the level of pneumonia hasn't changed. Yeah. So although there were some other differences. So I would like to call everyone to contribute into discussions that will take place later. Now I would like to invite Mr. Borisevich, who is a director of the Central Research Institute from the Moscow Oblast. Thank you very much for this opportunity to take part in this very important international forum. And I'm going to speak about the structure and functions of the virus of atypical pneumonia. And this family of viruses, okay, they lead to various gastrointestinal conditions. They also have this MERS and Far East variants and COVID. So the particles of the virus, they get attached to cells, and they create chains of RNA. The most important thing is that they remain stable once they get into the cell. There's an interesting fact that there's this protein membrane, or this envelope, yeah, and also there are these receptacles, and there's like a crown made of these receptacles. And the family of these viruses was identified 54 years ago. This is the classification of different coronaviruses, and they are grouped in terms of the severity of this disease, and the taxonomic committee subdivided different strains and variants. As for the pathogenic viruses, pathogenic for people and animals, okay, this has been studied a lot. And here you can see the list of pathogenic viruses for animals. There are so many different viruses in this group. So we see here a clear-cut picture. Okay, 4 proteins, 8 additional proteins, and RNA codes 27 structural proteins. It is 1/3 of the genome of the virus. And it is important to underline that 14 translation frames have been identified, and also there are different open frames, and research is going on, and we are going to learn more about these structures. Here in the slide you can see all these structural proteins with their functionality. What is important, it is glycoprotein. Yeah, it ensures attachment to the cell, and it is responsible for penetration into the cell membrane. Then there's M and E proteins. They also play a significant role in replication of this pathogen. It is important to speak about the described structure of various proteins, and only 11 non-structural proteins. Their function is not quite clear. And at the same time, we see that these functional abilities of all these proteins, they are being studied, and they all play an important role in replication and virulence of this virus. All this knowledge identifying the function of structural, non-structural, and additional or auxiliary proteins, it's all compared to the phylogenetic tree of strains of studied viruses, and you see there's 5,600,000 different genome sequences. So thanks to these data, it is possible to study this and expand our knowledge on this pathogen. Equally important is sequencing of mutations. So we see that these mutations occur in different parts of the genome, but it is important to identify what it gives. And I would like to stop at this Delta, the latest Delta variant, and this is the most infectious and most prevalent these days. In fact, when it appeared in India, the incidence grew 20 times, and it was the main reason for a higher incidence or third wave of coronavirus here in Russia and in Great Britain, and a lethal outcome was also very high. Omicron was identified recently in November, and there's 32 mutations, and lots of them demonstrate that it is highly transmissive and it is resistant to vaccines. And also these sticky proteins is also different. We haven't seen any publications about this strain yet, but we are absolutely sure that our knowledge will be growing. This is a unique slide, and actually it is in line with what the previous speakers were speaking about lower protective functions of vaccines. So here of the major 5 strains of virus COVID-19 are shown, and we see here the British. Okay, see that all these numbers, and the Indian, okay, 3 times different. Okay, the reduction of this resistance, okay, if we compare it with what we have now, okay, 8% difference. So, and if the protection is 91%, this is for Sputnik, minus 8%, it is 83%. So it is still not very significant. So it is an indication that it might be effective against Omicron, but it needs to be studied. This is a 3D image of this protein. The next speaker is going to describe it in detail, so I'm not going to show it here. And okay, different sites of maturing, and S1, S2 division points. Right. This is the whole cycle of replication. This is not new. And on the right, this schematic interaction with the target cell, and this protease and furin, okay, they subdivide the protein first, and then this liposome route is taken by the virus to get into the cell. The virulence. Okay, so here we speak about enterocytes of a thin gut, and these receptors, it is angiotensin transforming agents. They are all relevant in this case. Now, mechanism of infecting. This is pulmonary tissue, and we see exactly where there's this replication and protein division, and here we can see analyze the level of pathogen power of COVID-19 in comparison to SARS-1, because SARS on the 4th day had 7.6, and here, on the 2nd day, we have the maximum peak. And in conclusion, I would like to say that the morphological features of this virus, okay, it is typical for the whole family of viruses, and it has unique functions of transmission from one person to another. This depends on the structure of proteins. And during the evolution of this virus, its genome is quite different, with lots of nucleotide changes. And the new variants might be dangerous, and they are also of interest. There are 6 major lines, and it is T6. Okay, it includes all of these major elements, and Delta is still prevailing in the world, and it has very high incidence. Its incubation period is lower, and also the severity of this disease is much higher than the original version. And in the coming years, the permanent threat will be spontaneous appearance of more virulent strains of SARS-CoV-2 virus. Thank you very much, Sergei Vladimirovich.
Thank you very much for being for a most interesting presentation and for being within the framework of the time allocated. Another presentation for the morning session, for the plenary session, by Vasily Akimkin, Director of the Central Research Institute of Epidemiology of Rospotrebnadzor, Molecular Epidemiology of COVID-19. Dear colleagues, allow me to speak about the main aspects of my presentation. I will speak very briefly. Now, we examined coronavirus in detail, and in many of the presentations, this has already been mentioned. The database we have accumulated for the virus, so the phylogenetic analysis, all this can be checked and tested through the use of the different existing systems. 3 parts of the protein that are in the basis of the coronavirus are very often mentioned. S protein is possessing great variability, and we speak most often about it. Epidemiologically, we need to speak about the mechanisms of transmission, airborne and contact, and I will speak about diagnostics rather and of the new coronavirus infection. Now, whenever we study the examination of the infection, that's diagnostics, and PCR diagnostics is in the basis of the examinations today. Russia is number 2 by the overall number of tests in the world and by the correlation per 1,000 people. For that ratio. Our institute is involved very actively into this work. We have for over the past 18 months, and we can say that since the beginning of the pandemic, of the 5 million tests were taken with PCR, then 1 million different enzyme analysis, and 20,000 genomic tests. And one of the systems created very rapidly was the system which is still being used, and it's the system, the sensitivity, diagnostic sensitivity is over 1,000 copies for 1 milliliter. The diagnostics is carried for SARS, MERS, and COVID-19. The second system is Ampli system, and it's a unique system. It makes it possible to carry out quality and quantity assessment, which is most important today, both for the positions associated with the quality of treatment, epidemiological threat, and manifestation of those, and also helps to discover virus in the environment. But then there is a question that emerged at the end of December last year, when we had to speed up the work on the analysis of the tests. And so isothermic amplification made it possible to create the 2 new tests. So one is being worked on. 2 tests, 2 assays were prepared within a very short period of time, just within a couple of months, and we were able to register the systems. The first assay is classical. It makes it possible to define the S protein mutations. The second assay is for mutation 501, January this year. Now, time flies indeed. British, South African, and viruses and Brazilian viruses. They were all with mutation 501. So there is a question, of course, is that has it reference to this particular categories or not? But anyway, for us, it was most important from the point of epidemiology, first of all. These assays are good in the following way. They make it possible to carry out the diagnostics within just 1 hour, contrary to the classical assays, the PCR assays for two targets. Actually, assay is a topical one indeed. It's one of the first attempts in the world, and it's carried out by the specialists of our institute. We can see here that to a great extent there is a mutation obvious in ACE protein and in other parts of the genome, of a virus genome. And at present, in order to improve the reliability and to avoid the false results, we create the assay for two targets in genome, and which will make it possible for us to increase the reliability of the results. And I'm quite sure that the assay will be finished quite soon, and manufacturing will begin, and it will be registered next year. A very important aspect is associated with the circulation of viruses among the healthy population, provisionally healthy population. And we are following this trend over the past 18 months. And you can see here this dark wave. The lighter color, that is the incidence, and the level of circulation among the healthy population now makes it possible to forecast the increase of the incidence. Rospotrebnadzor, on the basis of our institute, and on the basis of the government resolution, number 448, we have created a base which assimilates all the data, accumulates all the data associated with the sequencing of the polygenomic sequencing and fragmented sequencing. And at present, we can say that we do have a scientific consortium with 27 scientific institutions, and there were 44,000 when we were preparing the slides, but last day we actually went beyond the 48,000 full genome and fragmented genome elements, which are important for us in the context of the analysis. You can see this distribution for a full genome and a fragmented genome. And next, we can say that to a great extent, this is the basis, epidemiological basis, enabling us to resolve many of the problems associated with the forecasting of the mutation and the circulation of the virus. Now, we have modified the SGS panel, and thus we can carry out the work on sequencing of the S protein as such, which speeds up the positions associated with the sequencing and makes it possible to improve the quality of sequencing. And several NGS panels have been prepared by our professionals, and at present, as a result, we can quickly tackle different issues, and the cost is lower than that proposed by foreign companies. SGS panels incorporate all the mutations, and they have been modified by us many times in order to analyze the sequencing of S protein and to carry out the complete genome sequence quickly enough. At present, when we speak about the sequence of the complete genome, now we can say that we have loaded into the database, into the Russian platform, over 21,000 of complete genomes, among which you will find a lot provided by Rospotrebnadzor and the Flu Institute. Altogether, about 80% of all the full genome sequences analyzed in the Russian Federation. And this is the slide that represents the situation Here you can find the Russian part of GISAID, and to the right, the Russian platform. If you take the full genome sequences, then the Russian database is over 2 times bigger than the GISAID platform. Now you can see that a great contribution was made by the Rospotrebnadzor Institute and by the Flu Institute. Now, at present, WHO has looked at the monitoring of different genovariants, and you can see there is VOC variants, and then there are variants that present interest and the ones that require monitoring. Now, the positions of WHO changed many times, and at present, after the final revision, they include the Omicron, which became quite topical since the 3rd of December. The latest updating by WHO is of the 26th of November. Omicron. Omicron is the latest of the viruses that have 45 mutations altogether, 32 in S protein, and is different from Delta in this particular sense. Now, in the Russian Federation, we have found many of the genotypes or genovariants that required analysis, and the lambda mu, and last week 2 cases of Omicron. These were arrivals from South Africa. That's how the situation changed with the spread of the dominating genovariants in the world. And you can see that starting with mid-year, the dominating invariant is Delta. Again, you can find it here. You can see that among all the genovariants that are being found in Russia, over 80% are Delta. In the Russian Federation, the dynamics of the replacement occurred in the following. Up to April, May, this year, we were able to see different gen variants, and starting with May, Delta is dominating. And so that is the present-day situation, which is associated with the spread of Delta and different variants of Delta. Yeah. Now, here is another scheme emphasizing the dominating of Delta and the structure of Delta, which depends on the type when it was observed. At present, according to the latest revision, now the position of dominance is adopted. AIY1 to 2. These are the characteristics, and 90% of all the revealed cases are Delta, AIY1 to 2, and it was renamed on the 26th of November. Now we're talking about the Delta structure, I122, AY122, and some other structural positions we can see here. The structure of Delta is varied, and it has always been like that since the moment we started monitoring it. According to our analysis, analysis of the data bank, we can see about 30 sublines of Delta, which are in the database, and we analyze those. At present, we can see the evolution of Delta. We can see its development, and we can see its multifaceted character and the different sublines we have been observing through this year, following the analysis of the database. Thus, the active process of the evolution of COVID-19 happens. The genetic variant Delta AY is dominating in the Russian Federation. Its share among all the other variants is over 97% at present. We can see dissociation between the dominating gen variant Delta, starting with the registration moment. It's the variant which is called Y122. Previously, genomes of this variant were allocated the maternal variant B16172, but AY122 in the structure of subvariants in Russia used to be 85 to 91%, and in October this year, or since October, it amounts to 94%. Apart from AY122, there are other subvariants of Delta. As a maternal B16172, the share over the past 3 months just 5%, AY82 4%, AY92 2%. The other subvariants are represented by individual cases which are also identified and amount to just 1% of all the sequences of Delta. The dynamic change of the subvariants does not have a very significant impact on the intensity of the epidemic process and the severity of the clinical disease. At present,
the Lambda and so 37 and so on. Okay, these variants are absent, and there are no epidemiological outbreaks with many cases. Now there are 2 Omicron cases which have been confirmed. Okay, it is among those people who came from abroad. With the growing numbers of Omicron cases in different countries, it is advisable to continue monitoring of this genotype among those who enter the territory of Russia from those countries where the epidemiological situation is not favorable, and regular monitoring over circulation of this infection and these Delta subline. This is the basis for epidemiological oversight and epidemiological forecast. Thank you for your attention. Thank you very much. Dear colleagues, we have listened to all the presentations which were included into the plenary session, and I would like to thank all the speakers for these most interesting reports. And you touched upon lots of topics that will give us thought for discussions. And after a short break, at 12:10, we are going to continue the work of our sections. And I wish you all success and really hope for important results that will be generated through these discussions and those solutions that will be identified. Thank you, and see you in 15 minutes.
Спасибо.